Hello and thank you for subscribing to Infoverse Tech, where we explore new technologies, upcoming trends in the areas of artificial intelligence, machine learning, big data, and so on. Today we are introducing Python Profiling, which is a library to allow quick data analysis. So this is a high-level overview. It just shows how to use this library, and if you're in a hurry, you just need to take a look at your data, do some quick analysis. This is a very good tool to help you achieve that objective. So let's get started. As always, I'm importing pandas as PD, so that's the pandas library. I'm importing Seaborn as SNS. It's a Python data visualization library based on matplotlib, and we are now introducing Pandas Profiling. So that's the syntax: importing profile report from pandas underscore profiling, and the pandas testing is something that also is required for this to run properly. So let me select that and run that, and let it finish so we don't see any issues. Okay, let's see. I did include that, so it's deprecated. Use the function in the public get import. Okay, let's rerun that. So probably you'll have to investigate a little more, and as it suggested, that's probably deprecated, but anyhow it's taken the command. Now let's move on to the next step. So as mentioned in the introduction, Pandas Profiling, it generates a profile report for a pandas data frame, and you can find some examples at its website, which is at pypi.org/project/pandas-profiling. Now let's go ahead and read some data. So I have a variable called Titanic underscore dataset, and I'm using the sns.load underscore dataset command to load a dataset. I'm here, you can see I'm loading a dataset called Titanic, and this is part of a part of datasets that are available with Pandas Profiling, as examples, just to get you started quickly. And if we access the GitHub site, we can see there are other datasets as well. I've just mentioned some like MPG, car underscore crashes, etc. Let's quickly go there and take a look at this is the site that I'm referencing there, and all of these data are built in. You can start using them immediately. So I chose Titanic.csv. This is the Titanic dataset, and like I mentioned, MPG, car underscore crashes, flights, a number of other data sets are available here. So if you want to just explore, you can use any one of these, and the way to do that is to simply mention it here. So if, let's say as an example, I was to use the flights data set, I'll just replace Titanic with flights, and also give my variable a similar name, like maybe flights dataset or something. So let's run that. Okay, that ran well, no issues. Let's take a look at the first top 10 rows. Let's run that. Okay, so it provides us some the data frame that's in that data set. So you can see there are a number of attributes: survived, the sex of the passenger, male, female, the age group, the fare that they paid, where did they embark from. I think I know S is for Southampton, and there are 3 or 4 locations where the passengers embarked. That's the information that they have. What was the class of their booking? Was it third class, first class, and so on. Some detail about whether it's a man, woman, or child. Embarking town, yeah, sorry, here's the information. So Southampton, Queenstown, and so on. Alive, and another attribute which says was that passenger alone. So we'll see what are the correlations, and this is a great data set to get started to learn about working with pandas and pandas profiling. Let's describe this data set, and we see that you have about 891 counts or data in this data set. The describe command quickly calculates the mean, standard deviation, and so on. So this is a quick look at the data. What are the maximum values, what are the minimum values, and so on. The 50, 25, and 75 percentiles. So now I'm running the actual profile command, which will use the profile report to generate the profile that we want for the data analysis in like HTML format, so we can browse and move from one variable information to the other. So the syntax is just some variable profile and profile report. Do note the case sensitivity. I'm using Titanic underscore dataset. This is the variable that I used to put in my data or read the data in, and this is optional. I just adding a title just to make it look good. So let's run that, and hopefully it runs well. It does take a little time to generate that report, and you can see by the asterisks here that it's running in the background. So let's give it a few seconds and it should show up on my screen very soon. So while that's happening, what else can we look at the data here? So one thing to note is that there was some controversy, and there was a correlation between the class of the passenger. So if you were first class, you had a higher chance of surviving, and so on. So we're gonna see if that really is true when we look at the data. So let me run that, and here you go. So here's the data set. This is a quick overview. So as we had seen in the describe, there were like 891 observations or data. There's some duplication there. What's the total size, and so on. And it also provides details of the attributes or the variables. So 4 were numeric, categorical are 6, Boolean are 4 are Boolean type, and so on. So let's go down. When you talk about the variables, let's look at some of the information here. Adult male, so 537 were adults, 354 were not adults. We can also click this to toggle details just to get a little more details. So just breaking it down into percentage, we can close that. When you talk about the age, you have 89 different ages or distinct age groups. The mean was about 30 years or 29 and .699. The minimum was, it appears to be a very small infant, and the maximum, the eldest passenger was 80 years old. There's some missing information now. So again, if you needed to do a deeper analysis, you would probably make some changes to the data set, but for our purposes, for a quick overview of the data, this is a good tool. So being alive, there are 549 expired, 342 were survivors. When you look at the attribute alone, so 537 were alone, 354 were not alone. We talk about the class, so you had 491 in third class, 184 passengers in second class, and 216 in first class. Let's see what other details we have here. Nothing much. Those are the towns. Okay, let's take a look at the fare. So there are 248 different types of fares that are captured in this data. The mean fare was $32. So this is remember, this is 1930s or perhaps earlier. So $32 is a lot of money at that time. The maximum was $512, and we can surmise that somebody paying $500 100 years back would probably have been a rich person and be placed in first class. Let's toggle the details if we have anything that stands out. So again, we can go into detail and look at a lot of other statistics here. Let's look at the sex. So there are two types, either it's male, female. So 577 males, 314 were females. The survivors, so 549 did not survive and 342 survived. So it's a Boolean, you either survived or you didn't survive, and that's how it's presented here. Let's toggle the details. Again, it's just giving a percentage value. The category, so there are three types, so man, woman, child. So 537 were men, 270 were women, 83 are child. Let's do the toggle. So it just provides so about 10% of the passengers were children. Now let's take a quick look at the correlation. So if you see red, that means it's a high correlation. And again, for an adult male to adult male, if you look at the intersection here, it's red. It's the highest intersection. Again, it's the same variable, so it will have that, and we follow that same pattern. So age, with age, it's high. So the closest to this are these pink colors. So let's take a look. Earlier in the video I mentioned the controversy, and the controversy was that if you were a high class passenger, you had a higher chance of surviving because they were provided those lifeboats and were provided at a priority to the other passengers. I'm sorry. So let's take a look if we can perhaps find that that correlation here in this. So, and just to quickly mention, we're just looking at the Pearson's R, but there's Spearman, Kendall's, Fick, Kramer's again. So depending on your choice, you can use any one of these to find the data that you're looking at. So let's look at Pearson's. Let's take a look at fare. So if I paid a fare, my survival rate was definitely a correlation. So higher fare, you had a higher chance of surviving. If you're alone and you're an adult male, that also shows a correlation. Let's take a look at the age factor. So with age, what do we expect? Perhaps a younger person, like a young man or young woman, would have a higher chance of surviving. Adult male and being alone has a high correlation. So you had no dependence. You could jump or move quickly towards a safe area or into a boat, rather than if you're with a family and you have that to care for them as well. So this was what I just wanted to share. You have correlations, you have a lot of information just by running a few lines of code. So just to recap, Pandas Profiling is a great library to quickly look at your data and do a quick analysis, and then you can dig deeper in using other tools. This just talks about some maximum values, and this one just gives you a quick peer into your data set. So the first 10 rows and the last 10 rows. So as we saw in the data, about 891 observations. So this is the last 10 rows, these are the first 10 rows. So this concludes our very short review of Pandas profiling. I would urge you to go ahead and explore this further. At the same time, I would encourage you to use the other data sets as we mentioned. So go ahead and use the MPG or the car underscore crashes or the flights, just by replacing Titanic in that line over there. And that's it. And just as a quick note, as always, the code for this tutorial, the Jupyter notebook, is available here at github.com/infoversedev/main. Thank you very much. Thank you for subscribing, and stay tuned for more videos in this area.